April 1st, 2026. 4 astronauts strap into a capsule on the same launch pad that sent Neil Armstrong to the moon. They don't land on it, not yet, but they fly around it, farther from Earth than any human being has traveled since 1970. And they come home safely. That mission was Artemis II. And its success didn't just make history, it started a countdown. Because now, everything humanity needs to return to the lunar surface is being built, tested, and assembled. And before anyone sets foot on the moon again, one more mission has to happen first. This is Artemis III, and it may be the most complicated thing NASA has ever attempted in low Earth orbit. More than 5 decades have passed since humans last walked on the moon. On December 14, 1972, Apollo 17 astronaut Eugene Cernan climbed back into the lunar module, looked down at the dusty gray surface one last time, and left. Since that moment, no human being has stood on another world. NASA's Artemis program was built to end that silence. The first mission, Artemis I, launched in November 2022, an uncrewed test of the Space Launch System rocket and the Orion spacecraft. Orion traveled around the moon and returned safely after 25 days in space. A flawless dress rehearsal. Then came Artemis II. Launched April 1st, 2026, it carried 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen, on a nearly 10-day voyage around the moon. At their farthest point, the crew traveled over 252,000 miles from Earth, breaking the all-time record for the greatest distance humans have ever traveled in space. A record that had stood since Apollo 13 in 1970. They flew farther than any human in living memory, and they came home. That mission proved the rocket works, the spacecraft works, the crew can survive deep space. But landing on the moon, that requires something else entirely. Here's the thing NASA learned from Apollo that most people forget. In 1969, before Neil Armstrong took a single step on the lunar surface, NASA spent months running a mission called Apollo 9, entirely in Earth orbit. Its sole purpose was to test the lunar module, dock it, undock it, fly it independently, bring it back. Only after that was proven did Apollo 11 get the green light. NASA is doing the exact same thing now, just with a far more complex set of vehicles. Because returning to the moon in 2026 isn't a government mission with one rocket and one lander. It's a collaboration between NASA and the biggest private space companies on Earth. And it involves 3 different spacecraft that have never flown together. That's the challenge Artemis III is built to solve. On February 27, 2026, NASA Administrator Jared Isaacman stood before cameras and announced a major change to the Artemis architecture. Artemis III would not attempt a lunar landing. Instead, it would become a critical proving ground, a crewed mission in low Earth orbit designed to do something that has never been done before. Test 2 commercial lunar landers with astronauts aboard simultaneously. The crew was announced just days ago, on June 9, 2026. 4 astronauts, Randy Bresnik, Frank Rubio, Andre Douglas, and ESA astronaut Luca Parmitano. They will launch no earlier than 2027 aboard Orion on the Space Launch System from Kennedy Space Center in Florida. But Orion won't be alone up there. Before the crew even launches, 2 other vehicles will already be waiting in orbit. The first is Blue Origin's Blue Moon Mark II, a lunar lander being developed under NASA's Human Landing System program. It launches separately, gets itself into orbit, and waits. The second is SpaceX's Starship Human Landing System, a modified version of the most powerful rocket ever built, also launched separately into Earth orbit. And then, Orion arrives. What happens next is essentially a high-stakes orbital ballet. Orion will perform rendezvous and docking operations with both vehicles. Rendezvous means two spacecraft maneuvering toward each other across the void, no margin for error. Docking means physically locking them together. It is, without exaggeration, one of the most technically demanding operations in all of human spaceflight. Now imagine doing it with spacecraft built by three entirely different organizations, using different systems, different software, and different docking mechanisms, all while 4 astronauts depend on every connection being airtight. The mission will also evaluate the next-generation lunar spacesuits developed by AXIOM Space, suits specifically designed for the Moon's surface and the unique hazards of the lunar South Pole. Every system, every interface, every procedure, tested in the relative safety of low Earth orbit, where a rescue is possible, before trusting them 250,000 miles away. The full mission is expected to last approximately 2 weeks. Some might ask, why not just go to the Moon? Why add another mission? The answer is what makes Artemis different from anything that's come before. Apollo was a single government program with one rocket, one lander, one chain of command. If something went wrong, there was one team responsible for fixing it. Artemis is something humanity has never tried. A crewed deep space program built on commercial infrastructure, where NASA's Orion depends on a SpaceX lander and a Blue Origin lander to get astronauts to the surface and back. These are independent companies with independent systems. And before you trust those systems with human lives on the surface of the Moon, you test them, together, in orbit, with people inside. That's what Artemis III is. It's not a consolation prize for not landing on the Moon. It's the reason the Moon landing will actually work. Artemis IV is currently planned as the first mission to return astronaut boots to the lunar surface. The first human footsteps on the Moon since Eugene Cernan walked away in 1972. But it only happens because Artemis III happens first. More than 50 years after the Apollo era ended, humanity is not rushing back to the Moon. It is doing something harder and more deliberate, building the architecture to stay there. Artemis III is the last proof of concept before the proof becomes history. The Moon is waiting, and this time we're not just going back, we're going back to stay.